is asking you on specifically explain ketogenesis and ketone bodies. So as I mentioned earlier on, the question here, the hint is on the marks, 20 marks. So you expect something that is longer lah, 20 sentences. Okay, so let me use our lecture notes to explain on this as a recap for everyone as well. Okay. So under lipid metabolism, you will learn the first part, basically how we utilize lipid to gain energy from lipid. Okay, and the second part of lipid metabolism is for us to understand the process of ketogenesis, ketosis, and ketoacidosis. All right. So under this, these are the things that we need to know. So again, looking back into the term, ketogenesis basically means, genesis means to produce, to synthesis what? Ketone. Okay. Ketosis is a state. Ketogenesis is a process. Ketosis and ketoacidosis is a state, a condition. So the person is having ketosis or ketoacidosis. Why this person is having ketosis and ketoacidosis? Because of the process of ketogenesis. So don't get confused. Ketogenesis is the mechanism. The condition is called ketosis. Okay. All right. So ketogenesis happens when there is an imbalance of lipid and carbohydrate metabolism. Okay, for example, there's accumulation of acetyl-CoA. So there is one state. Okay, or we have low glucose. So basically ketogenesis happens when you have too much of lipid compared to carbohydrate in your body. So how does that happen? Is when you have accumulation of acetyl-CoA or when you have a condition where there's low glucose in your body. Okay, so when ketogenesis takes place, or why? Because of, for example, some people, they practice keto diet. They don't take carbs, tak makan roti, tak makan nasi, and things like that, anything carbohydrates. So they increase their consumption of lipid and also protein. Macam itulah, biasanya we don't eat carbs lah basically. So there is people that go for keto diet. So it is claimed to be like faster lah in terms of reducing weight macam tu. But that is yet to be confirmed lah, scientifically confirmed. Okay. Sometimes some people, they have diabetic condition. So what happened? Although there's intake of glucose, but it's not being processed or being metabolized. Okay, so our body is, although we have that glucose, but it's not being metabolized. So macam tak cukup glucose. Padahal ada, the glucose is there, but it's not being metabolized. Okay, or in a condition of prolonged fasting or starvation. Okay, so even the glycogen supply are exhausted. Okay, so again, low glucose. So these are the three conditions that leads to the process of ketogenesis to start taking place. Okay, so what happens? These three things happens. Okay, either one of it happens. So next is ketogenesis. So when there's ketogenesis, uncontrolled ketogenesis, it leads to ketosis. Okay, and ketoacidosis. Okay, so this is the first part of lipid metabolism. Basically, we try to understand the oxidation of fatty acid. Okay, you can go through this later. We have three main steps. Okay, the activation of free fatty acid to acyl-CoA, and then we have the transport of them. So this all happens inside the mitochondria, and eventually we have beta oxidation. Okay. So if you notice over here, one of the product of oxidation of fatty acid would be acetyl-CoA. So if there is an increase of fatty acid dekat sini, so increase in fatty acid, free fatty acid, maybe due to our diet, what will happen? It's indirectly increasing the amount of acetyl-CoA. So that is why earlier on, the reason ketogenesis takes place is because we have accumulation of acetyl-CoA. So how does this acetyl-CoA accumulate? because one of the reason we have a lot of free fatty acid in our body. So that is how lah the relation. Okay. So under ketogenesis, it allows the liver to oxidize the increasing amount of fatty acid, okay, without increasing its total energy expenditure, and it's actually basically the feedback mechanism for survival. Okay, so in general, ketone bodies are safe for us. So it's just our feedback mechanism. If you don't take carbohydrate, then our body will kickstart ketogenesis eventually, okay, for survival. So it's actually ketone bodies are normal fuels of respiration. Okay, in some organs, for example, our heart muscle or the renal cortex in our kidney will use ketone bodies, will prefer ketone bodies compared to glucose. Okay, and also ketone bodies is actually the backup plan for our brain. Okay, let's say in condition like prolonged starvation, when you don't have glucose anymore, but our brain still needs to function, then they will start to utilize ketone bodies. Okay, so again, this is the three things that trigger the start of ketogenesis. When you have a lot of fatty acid, so high fatty acid concentration, or when you have low glucose level, or in diabetic condition, you have glucose but unable to metabolize them. So these three things will lead to ketogenesis. Okay, so ketogenesis is the synthesis of ketone bodies. So ketone bodies, we have three molecules that falls under the category of ketone bodies. They are acetoacetate, beta hydroxybutyrate, and also acetone. So these three things are actually ketone bodies. So ketogenesis takes place in the liver, okay, utilizing the acetyl-CoA just now from fatty acid oxidation, the acetyl-CoA, okay, as the starting point or precursor. Okay, and the enzymes responsible are mainly inside our mitochondria. So ketogenesis, the location is, or the site of reaction is within the liver, okay, whereby the main enzymes are associated with mitochondria. Okay, so going back to the question just now, it's asking you to explain on ketogenesis. You can use the same method as I explained on carbohydrate metabolism just now, which is basically you can write in the main points like the definition. So you explain what is ketogenesis. So the production of ketone bodies or the synthesis of ketone bodies. Okay, then what is ketone bodies? So you can list out these three things, acetoacetate. Then you can go to the next point, which is where this reaction takes place. So site of reaction, liver. Okay, and then what is the starting point? Okay, refer back to the table. The precursor is acetyl-CoA. So what is the ending point? Okay, so you can write in all these what I like to call as secure points lah. If you can't remember all the steps, okay, at least you still can get marks on this information. Okay, and then you start to explain. So for ketogenesis, you can remember the reaction name and what happens under the reaction. So in that question in particular, you will get marks when you mention the name of the reaction. So ketogenesis, we have 4 main steps. The first condensation, so you get 1 mark. Second condensation, 2nd mark. Okay, chain cleavage, 3rd mark, and reduction, 4th mark. For every reaction that you explain, that's the additional mark. So if you explain first condensation, so what happens in first condensation? Basically, ketogenesis begins with 2 acetyl-CoA. Remember the precursor just now? Combine to produce acetoacetate-CoA. So 2nd mark lah. So this is 2 acetyl-CoA combine together and form acetoacetate-CoA. And then you explain on the second reaction. So what happens in the second condensation? Okay. So second condensation is similar to the first one. So first one is basically 1 acetyl-CoA combined with another one, combined together. So second condensation is basically this that is already combined adding on one more acetyl-CoA. Okay, and then producing HMG-CoA. Okay, and then for the third reaction is the cleavage or the cutting. Okay, HMG-CoA is then cleaved to acetyl-CoA back and also acetoacetate. Okay, and then this one is reduced because there's presence of hydrogen here. So this reaction is called reduction. So acetoacetate is reduced to beta hydroxybutyrate, and the reducing agent is NADH, forming acetone and beta hydroxybutyrate. Okay, so for ketogenesis, you can use the same approach as carbohydrate metabolism just now. What are your secure points in terms of the location, definition, site of reaction? Sama tadi kan? What are ketone bodies? Okay, and then you can move on to the names of the steps. So we have 4 steps for ketogenesis. First, condensation. Second, and then chain cleavage reduction. And for each step, you explain what happens. And this one, you can also, how do you remember this? Maybe mnemonics, okay? Or you can remember based on when you understand the name of the enzyme. Okay? For example, okay, kat sini, the product here is HMG-CoA. And the enzyme here is HMG-CoA synthase. So synthase is to synthesis, to produce. So if it's HMG-CoA synthase, what is it producing? It's producing HMG-CoA. So for this one, the chain cleavage over here, step number 3, because it's cleaving, right? It's cutting. So the enzyme associated to this is HMG-CoA lyase, to lyse, to break, to cut. Okay, samalah. So that is how you try to understand each of the reaction and why this enzyme is here, not here. Okay, because of the role of the enzyme. Right? So basically this is how you answer the question in the tutorial. Okay, you can explain back the definition and then you go one by one. Macam ni. Okay.
Miss, nak tanya. So macam tadi saya nampak ada macam like one full sentence like mana tadi 3-hydroxy 3-methyl tu. If we choose to just tulis HMG boleh ke?
Boleh.
Dapat point ke macam tu?
Dapat. Untuk ni
so
saya
tak perlu nak put full
tak perlu
tu lah.
betul. Cuma the short form that you use kena standard. I mean that you cannot create your own lah. So kalau ni dia memang
standard what we learn in
yes.
biochem lah. Okay.
Okay, so betul. So any points pun dekat previous question pun you can use the standard short forms lah. So cannot be something that you create on your own lah. Tapi I won't be too strict on in terms of the spelling lah. As long as dia tak lari terus the meaning or dia terus jadi molekul lain. Let's say lah kan fructose 6-phosphate ni you tulis fructose 5-phosphate. So salah lah. Tapi kalau you tertinggal H kat sini, tu tak apalah. So jangan macam change terus to another meaning or another molecule. Okay. Berapa soalan? Okay, so 3 soalan tadi. So far okay ke? Is there any subtopics that you want me to explain further?
Setakat ni tak ada lagi. All okay.
Okay. So let me check on your Okay. So inilah yang kita dah supposed to cover. Okay, intro ni very basic lah on the application itself. And then cellular biomolecules ni is basically on you understanding each of the organelles. Okay, why is it important? Cellular biomolecules ni is basically contohnya set of reaction tadi at mitochondria. So you need to be able to imagine, okay, mitochondria ni dekat mana? Okay, inside the cell ke? Is it mitochondria tu apa? Okay, so that is cellular biomolecules. And then water and pH ni is basically the main points would be on you understanding the role of water in biochemistry process, biochemical reaction. Okay, and then amino acid and protein ni is very general. So if you notice, biochem ni dia akan ada 4 main biomolecule, which is protein, carbohydrate, lipid, and satu lagi apa? Tak ada 3. Bukan 4. So 3 biomolecules. Okay, so untuk macam contoh kan, amino acid and protein, usually the chapter ni, the thing that you need to remember is basically what is the significance of this biomolecule to us. Kenapa, why are they important? And then for protein metabolism is the process. In general, this is in general je, how do we gain energy or ATP based on the metabolic reaction? Okay, so that is something that you will want to understand in metabolism. How do we get energy for them? How do we store them in our body? So same goes to carbohydrate. So for carbohydrate chapter, you will learn the sources of carbohydrate, the significance of them. And then for carbohydrate metabolism is all the reaction. How do you get energy from them? How do you store them? Same goes to lipid. The significance, the sources of lipid. Okay, and then for lipid metabolism, we have 2. The beta oxidation part and then the ketogenesis just now. Okay, and then we go through, nantilah saya akan add on new lectures pula. Okay, on hormone, okay, muscle and so on food biochemistry. Okay, integration. So nanti in integration of biochemistry, we will look how carbohydrate metabolism ni ada kaitan dengan lipid metabolism. How they influence each other. Kalau ada satu yang ada masalah, for example, you have enzyme problem in carbohydrate metabolism, how lipid can support, how protein metabolism can support. Macam tu. Okay. Okay. So, so far no question for tutorial ni soalan ni.
Tak ada.
Kita break sekejap, 2 minutes macam tu. We come back to the same day. I brief you on your mini project. Alright?
Okay, boleh.